So this is homework number 6, problem 6.6, part A, and the question that's given to us says that a construction worker with a weight of 880 newtons stands on a roof that is sloped at 16 degrees. The question is asking us, what is the magnitude of the normal force of the roof on the worker? And it's telling us to express our answer to two significant figures and include the appropriate units. So the way I approach this particular question is I first drew a diagram of the given question, and as you can see, this is the 16-degree slope, and this particular point where the dot is where the man is, the construction worker. And we know that there are forces that are being exerted on the man because the man is at a standstill. We know that the gravitational force and the normal force are balanced and that the net force equals to 0. So here we have the gravitational force that's pointing downwards, and upwards we have the normal force, which is perpendicular to the surface here. So the question is asking us to find the magnitude of the normal force, and we find the magnitude of the normal force by getting the x components of the gravitational force and the y components of the gravitational force. We do that by taking the y-axis, extending it for a bit, and also taking the x-axis here and making sure that it's parallel to the x component of the gravitational force. So we know that this here, the x component of the gravitational force is parallel to the x-axis. So after that, we want to use the y component of the gravitational force to find the normal force. And we can do that by finding the angle that's inside here. So we know that the right triangle, the sum of all the angles inside a right triangle equals to 180 degrees. It's given to us that this angle here is 16 degrees, and this angle here is a perpendicular angle, so that's 90 degrees. And this side here is x, which is unknown to us at the moment. So what we do is we take the sum of all the angles, 16 plus 90 from the perpendicular angle, plus x, the unknown side, and we solve for x. We say that x equals to 74 degrees here. So we solve for this side, and this side is 74 degrees. We also know that because this here is a perpendicular angle, that the sum of 74 degrees and this unknown side would equal to 90 degrees, which means that this here is 16 degrees. We use this particular angle, the 16 degrees, to find the y components of the gravitational force for the normal force. So we use cosine. We say that the y components of the gravitational force equals to adjacent, and we say that the gravitational force equals to the hypotenuse. We say that here cosine 16 equals to the y components of the gravitational force divided by the gravitational force. Then what we do is that we solve for the y components of the gravitational force to find the normal force. So we divide by the gravitational force here, we multiply here, and this cancels out and we multiply on the other side. We solve for the y components of the gravitational force by saying that the gravitational force times cosine 16 equals to the y components of the gravitational force. So we have here the gravitational force that's given to us, which is 880 newtons. This is the force that the man is exerting while he's standing at this particular position. So we plug it in, we say 880 newtons times cosine 16 equals to 845.9 newtons. But let's not forget that the question is asking us to have our answer as two significant figures and to include the appropriate units. So because 849.9 newtons is not two significant figures, we round it off and say that it's 850 newtons. And we know that 0 is a trailing number and it's not a significant figure. So we write it off and say that our answer equals 850 newtons.